Hi, welcome to the Olympiad geometry. Let's continue our study on the intersection circles. Before we solve the problem, so if you find this video is helpful, please share, comment, and subscribe the channel. Thank you. Here is a problem. Let A be one of the two distinct points of the intersection of two unequal coplanar circles C1 and C2 with centers O1 and O2 respectively. One of the common tangent to the circles touch C1 at P1 and touch C2 at P2, while the other tangent touch C1 at Q1 and C2 at Q2. Let M1 be the midpoint of P1, Q1, and M2 be the midpoint of P2, Q2. Prove that O1A O2 equals to M1A M2. This is a problem from IMO 1983. Let's just look at the figure and try to find whatever we can find, right? So first of all, that M1 is the center of P1, Q1, M2 is the center of P2, Q2. So we know that M1, O1, M2, O2 are collinear, right? So I'll just draw the line. It's obvious. And we want to prove that angle O1A O2 equals to angle M1A M2. Right? O1A O2 equals to M1A M2, which means that equivalence to prove angle M1A O1 equals to angle M2A O2. Right? Equals to prove these two angles. So the first thing that we notice, how do we get the M1, M2 point? They come from the tangent point. They are the midpoint of tangent connection, right? So if we connect P1, O1, connect P2, O2, we know that O1, P1 is perpendicular with P1, P2. And O2, P2 is perpendicular with P1, P2, right? So O1, P1 is in parallel with O2, P2, right? O1, P1 is in parallel with O2, P2, which means angle P1, O1, M1 equals to angle P2, O2, M2, right? This angle equals to this angle. So we know that the triangle P1, M1, O1 is similar to triangle P2, M2, O2. So O1, M1 to O1, P1 equals to O2, M2 to O2, P2. Right? These two triangles, they are similar. Then let's connect. Remember that the property we learned from the intersection circles with a tangent. If we do the connection of the intersection point, right? We know that this line bisect the segment P1, P2. Let's call this point as D. So we know that dP1 equals to dP2. It's very easy to prove, right? Because dP2 is a tangent of O2. So dP2 squared equals to dA times dB, right? and dp1 squared equals to dA times dB. So dp1 equals to dp2, right? dp1 equals to dp2. Okay, so now we see P1, Q1 is perpendicular with O1, O2, and AB is perpendicular with O1, O2. P2, Q2 is perpendicular with O1, O2. So P1, Q1 is in parallel with AB and also in parallel with P2, Q2, right? And we know that dp1 equals to dp2, which means if we find the midpoint, we call it M, right? Then we know that M1 equals to MM2, right? Because because dp1 equals to dp2, the ratio of dp1 to dp2 equals to the ratio M1 M to M1 MM2. So MM1 equals to MM2. And from here, we got AM1 equals to AM2, because that AM is perpendicular with MM1, and also MM1 equals to MM2. Then we get this one. So now let's put all of these we got back to the ratio here, that since O1M1 to OP1 equals to O2M2 to O2P2, right? And O1P1, that's the radius of circle C1. It's same to O1A, right? So O1M1 to O1A, right? Equals to O2M2 to O2P2. O2P2 equals to O2A. Right. And O1M1, look at the triangle AM1O1, and we use a sine. We use a sine theorem that we can get O1M1 to O1A equals to sine angle M1A01 to sine angle AM101, right? And we know that it equals to M2O2 to O2A, that is sine angle O2 AM2 to sine angle O2 M2A, right? Now look at angle AM1O1. Since AM1 equals to AM2, we know that angle AM1O1 equals to angle AM2O1, right? So this can be rewritten as sine M1A01 to sine, here is AM1O1 equals to AM2M, right? Angle AM2M, right? And sine AM2M equals to sine 180 minus AM2M, which is sine AM2O2, right? So it equals to sine angle M1A01 to sine angle AM2O2. And we know it equals to this one, which is sine angle O2AM2 to sine angle AM2O2. So from here, we know that sine angle M1A01 equals to sine angle M2A02, right? Because the denominator are equal, so we got this one, and which means angle M1A01 equals to angle M2A02, right? M1A01 equals to M2A02. Therefore, angle O1A02 equals to angle M1A M2. Okay, so although it was an MO problem, it's medium difficult, slightly on the easy side difficulty problem. It's not a very tough one, because the first thing that we know from this problem, that we want to prove the two angles to be equal, right? And we know that circle O1 and circle O2 are unequal, which means that we need to find the relation of these angles from O1 and M1. And the thing that we know from the O1 and M1 is the ratio that O1 and M1 to the radius R1 equals to O1 and M2 to the radius R2. And based on that, we know that if we want to find anything related to M1A, angle M1A01 and angle M2A02, we need to put it back to M1, the side M101 and the side M202, right? And based on that, we can just try to find the relations as much as we can to figure out the that eventually AM1 equals to AM2 and the problem is solved. Okay, I hope you like this problem. I hope you like this video. See you in next one. Thank you.